All right, Marissa, I think we can go ahead and get started if you want to take it away.
Yes, thank you. Okay, so thank you everyone for joining us today. This is the Biomedical Engineering Graduate Program faculty panel. So we have faculty on this call to answer all of your questions. So make sure to find the Q&A button. Let me see if I can find it. It might be under more on your screen, but if you find the Q&A button, you can type all of your questions there and we will answer them. I will pitch them to the panel, but we can also answer them as we go along. So please feel free to ask any questions that you might have about our graduate programs. So, um, before introducing the panel, I just have a few slides just to tell us a little bit more about uh, our programs at Brown, and we will go from there. Okay, so first of all, I start out with location. So for those that don't know, Brown University is located in Providence, Rhode Island, which is the smallest state, but Providence is a lovely city. Um, it's about an hour train ride from Boston and about maybe about a 3 hour train ride from uh, New York City. And notice I kind of gave you the train and not the traffic because that can be very dependent. That Providence is located in a really nice area. You can get to cities if you want to, you can get to beaches, and you can get to mountains pretty quickly. I also wanted to mention our faculty. This is just some of our BME faculty. We're constantly adding BME faculty trainers to our list. We have a wide variety of faculty doing lots of different types of research. Some are hospital-based, some are based in the School of Biomedical, or the School of Engineering, I should say, and some are in the Division of Biology and Medicine. So, with that, there are so many different types of research. It's hard to put them all in buckets, but we can try. And we have 5 different research pillars here. So neuroengineering and neurotechnology, biosensors and bioplatforms, mechanobiology and biomechanics. So both soft tissue biomechanics and orthopedic biomechanics, tissue regeneration and engineering, and integrative biomaterials, which I like to call smart biomaterials. Really quickly on our program, so some of you might be interested in our master's program, some of you might be interested in our PhD program. Our master's program, we actually have 2. We have a master's of science, which is thesis-based, and we have a research track and a design track. And then we also have a master's of engineering, which is non-thesis based. The master's of engineering can be done in as little as a year, but it could also be done in 2 years as well. The master's of science is typically a 2-year program, and because of the design and research work. A co-op is available in all of the programs and tracks. And as a reminder, the application deadline for fall of 2026 is April 15th, although we do have a priority deadline of February 1st as well. For the PhD program, we are a direct match program, and we also offer 5 years of guaranteed funding. And the application deadline is fast approaching for the PhD program, and that will be for entry into fall of 2026. It will be December 1st. And if you're interested in applying, we can pay for your applications. So please, for master's student, those interested in the master's program, we have already captured your information. For those interested in the PhD program, I'll give you my contact information and you can send me a message at the end of this session. All right, so I think that's pretty much it with the intro slides. What I really want to do is introduce our faculty panel to you. So I will do that right now, and I'm actually going to stop sharing my screen so that you can see us all here. And maybe I will start with our newest faculty member, Dr. Tricia Chien.
Hi everyone. I'm really new here, so I'm learning those information as you guys here. But I have been here since September, and just like Marissa said, I love Providence and also the accessibility to almost everything here. I joined here in September, but before that, I was in another university in the United States. I'm an assistant director for the master's program but also teaching in the biomedical engineering program. So I'm happy to answer any questions that you have.
And we'll go to Professor Darling next.
I'm Eric Darling. I'm currently in the Department of Pathology and Laboratory Medicine. My educational background is as biomedical engineer, though. The research that we do in my lab typically revolves around mechanobiology, mechanics of living systems, typically at the cellular and tissue level of the organisms. We also do a lot of stuff with biomaterials and a little bit with sort of force sensors, again, looking at mechanics and drug delivery and the persistent delivery in the vasculature.
And then we can go to Professor Abdel Fattah.
Hi, my name is Ahmed Abdel Fattah. I'm an assistant professor here at Brown University. I started my lab here about 3 years ago, and we work on engineering proteins to record and image and manipulate brain activity. I'm in the Department of Neuroscience, but as you can already tell probably from this call, the BME program spans multiple different departments here at Brown. I'm happy to talk more about your interests in general if you have questions about research interests and so on and so forth.
All right, and last but not least, Professor Tripathi.
Yeah, I'm in Biomedical Engineering department as well. Thank you, Marissa, for organizing this. So I'm also in Biomedical Engineering department and in School of Engineering, and we are very excited to always welcome our new and best students. We do a lot of good research among the faculty. So thank you so much.
Okay, so please in the Q&A box in the Zoom toolbar, please ask your questions. I have a few already lined up for the panel, but feel free to ask anything you would like of them. The first question I'm going to ask is maybe to describe your research or your field of interest or your teaching, that sort of thing. So we'll start with Trisha, we'll start with you.
Okay, so my background is very maybe interesting here. So I got my chemistry degree from Colorado School of Mines. That's my PhD, and I was mainly focusing on nanomedicine, but with a chemistry angle. So designing materials for nanomedicine for drug delivery. And then I switched gear to Lawrence Berkeley National Lab, where I did battery research, lithium-ion batteries, so a lot of electrochemistry and a lot of synchrotron facility where I use high energy X-rays for characterization to understand the mechanism behind the batteries or the failure mechanism. And then I have been teaching almost 10 years now. My teaching has mainly, I guess, two areas. One area is on lecture, which focus on nanomedicine, but then the other part is design hands-on modules for students to really experience biology, materials, chemistry, more integrated. Since I joined here, I have been teaching biomaterials. It's a little bit challenging class, but I think it's very rewarding for students. So if you come here, we'll see each other there. But we are also very excited that we're developing a new online course, trying to map students for career pathways. So we're really trying to think for future, not just recruiting students here, but also guiding you guys to your next step in your career.
And Professor Darling.
Yeah, so I mentioned a little bit about the research that we do in my lab. My background is as my undergraduate degree was in just general engineering. So I always sort of was interested in a very wide topic of things. My more graduate level work was in cartilage and orthopedics. And so that flavors a lot of the stuff that we do in the lab. We have sort of a musculoskeletal tilt to a lot of the applications and translations of what we're trying to do. Like I said, we do a lot of work in terms of market scale mechanics. We've developed technology to be able to look at forces at the microscale in cell-dense tissues. We've developed, in collaboration with the National Institutes of Standards and Technology, cytometers to be able to look at the mechanical properties of cells, as we have a vibrant research thrust in that area. We've also used some of the technologies, again, for drug delivery, trying to mimic white blood cells in the circulation to be able to retain the drug delivery agents over time for days, potentially even weeks in the blood, and release drugs that way. All these things are obviously collaborative projects with other faculty, either here or at other places. That's the nature of the science that we do. Nothing's just sort of siloed at Brown, which is a great thing, in my opinion. It also makes it just a lot more interesting. One other area that we do research in is with adult stem cells. I teach a course on stem cell engineering, and that pops into a lot of the more regenerative engineering, tissue engineering type projects that we have in the lab.
Great. And then Professor Abdelfatah?
Yeah, so my research background, so I did my undergraduate degree actually is in pharmacy. I never worked as a pharmacist, but I liked chemistry a lot. So from there, I did my PhD in chemistry, and I did my PhD in a lab where we engineered lots of proteins. So by engineering proteins, I mean the molecular level. If you think of proteins as sort of the machines of life, you can change their properties by tuning different amino acids in them to make new functions in the lab that are not present in nature. My graduate degree, I worked a lot with fluorescent proteins like GFP and derivatives and so on and so forth. And we fused them to other sensor domains such that we can make biosensors that we can express in cells to record activity, biochemical signaling events of interest. So like, for example, my main work in my PhD was making red calcium sensors to look at calcium concentration changes in living cells in real time. It turns out that calcium is quite important in brain function and is a very good proxy for activity. And that's how I met a lot of neuroscientists who have been using my tools. So I did my postdoc in a neuroscience research intensive place called Janelia Research Campus, part of the Howard Hughes Medical Institute in Virginia, where I worked alongside many neuroscientists to really focus on tools that are useful for brain imaging, and that's what I continue doing today in my lab. We make tools to read out activity like electrical membrane potentials and voltage sensors and opioid or neuropeptide signaling events. And we also make tools to manipulate the brain like channel rhodopsins and so on and so forth. I'm happy to talk about any of the molecular details in detail with anyone interested.
All right. And Dr. Tripathi?
Yeah, so Marisa, this question about what is my research, isn't it?
Yes, your research. Yep.
Yeah.
And just to reiterate to everyone, so the participants on the call are both interested in the master's program and PhD programs. And I know all of you work with both master's and PhD students. So we'll have some questions to that as well. But for right now, Dr. Tripathi, you can talk a little bit more about your research.
Yeah, so I think it's good to see you all don't see you or see you. I think you are somewhere in the Zoom. So my research is mostly industry driven. So I have 3 companies funding my research right now, and we do actually a lot of biotech analytical device development. So we are developing ranging from new way of looking protein DNA or RNA characterization to all the way in relation to the clinical samples as well, but also on the another company is funding us on the neuroscience side, which is neurological biomarkers. So we have a lot of study going on with the hospitals getting their samples for early Alzheimer detection, because we came up with the technology to do that. And several others actually, which we are developing on the cell side. Also, we made a device which can do tissue dissociation in few seconds, which is very much desired for tissue to cell to sequencing or single cell sequencing. So we are developing those devices also. I do not have any funding from the government agencies. We all work for the industry-driven, product-related research. That's what we do in our lab. Thank you.
Yes, so the next question I have, it comes from one of our participants, and this question was asked on behalf of a prospective master's student, but I'm going to ask it as both a master's and PhD student. So the question is, are students encouraged or supported to publish research papers during their degree? And what kinds of collaborations with faculty or industry make this possible at Brown? So whoever wants to take that one first, can. And maybe I can start by saying that PhD students typically are required to publish, whereas master students are highly encouraged. And so I do have some statistics that I can pull up and share about how many of our master students publish either usually their last year of their master's program or the year after they graduate typically. So yeah, anybody want to, Eric?
I can. So, I mean, I can speak mostly to how we work in my own lab. So, when I train master students, when I train doctoral students, when I train undergrads, a lot of it is the same stuff that I'm training. And, all of it is geared towards research output in the form of a paper. A study really isn't done until it's been communicated. And so that is the ultimate goal of all the projects that are happening in the lab. The difference really is in the scope of the work. And so the doctoral students are expected to be publishing multiple papers over their time that they're here at Brown. A master's student, ideally, some of this is luck. If they have a project that works out, the idea is to be able to have a full paper from the thesis work that they're doing. That has happened in my lab for a couple of the students. More often than not, what happens is there might be multiple master student projects that end up going into sort of a single paper, or they go in as part of another paper that's led by a doctoral student. And then those master students are co-authors on those papers rather than a lead author. So it really depends on the project. It depends on how well things have progressed and what type of data and the level of impact that the master's project produced, and then how they can be put together in that short amount of time with a master's thesis to be able to get something that's publishable and put out as a paper. As Dr. Gray said, oftentimes this happens maybe in the last year. For me, it usually happens after people have graduated because it does take a while to get everything together. But I always try to keep in contact with all of my alumni to ask them questions and keep them engaged. If we do end up publishing a paper down the road, we want to put them on there if they were true authors and contributors to those studies.
Yes, and I'll go to Dr. Tripathi.
Yeah, thank you. You can call me Anubhav. Dr. Gray is amazing. I just want to start there to put together a thing, and very inspirational to all of our students, whether masters or PhD. So we are very lucky to have Dr. Gray in our program to coordinate this, make sure that we get good. So let me answer your question. Who's ever asked that about? So you got to think in a different way. So the thing is that as a master's student Brown, you would like to your two goals is your career, a master's or PhD, to your career, as well as our reputation as a biomedical engineering department at Brown, or reputation for Brown. So you're coming to Brown, and if Brown is accepting you, we are expecting you to perform at the best possible level because of our department ranking and everything depends on that. So it's onus on you to actually maximize your output in a variety of the ways which you're looking for. So obviously paper, publication, patents, your very, very good job, or your conference going, all of the above is very important to us, and we would like you to do that. And that's why you're coming to Brown, because it's a two-way street, not only to get opportunities for your career to work with us, but also you to contribute to Brown. You have to come to Brown's mission, or biomedical engineering mission, as set by Marisa and our leaders, actually. And Eric was our grad program director also, and the way he guided us in terms of of making our program the best to my ranking in the world, actually. So you definitely, yes, more the paper, the better it is.
Okay, great. Anybody else want to answer that question? Anubhav brought up a really great point in conferences as well. So as part of the program, you do have access to funding to attend conferences as well. So that's something that we highly encourage and support. In addition to a publication, maybe you go to a conference and do a presentation instead, or you do both. That's all of the above are very common. Yeah,
Yeah,
Patricia.
so yeah, I think I want to address the one part in that question is industry. So I think we have co-ops for master's students. This doesn't necessarily guarantee any publication. I think there's conflict of interest or confidentiality associated with that. But that will be part of your, I guess, outcome as well.
Yes, thank you. So as the part of the master's program, we do have co-op options. And so maybe in lieu of publishing a paper or going to a conference, you work at a company who might also publish papers and go to conferences as well. So that's a really great option. It's a really great not just experience, but also financial option as well, as you get to keep the salary you earn in that 6-month co-op. I might switch gears a little bit. And this next question is directed to Anubhav, but I'm going to open it up to everyone. What should an applicant talk about in the statement of purpose? I think both for master's and PhD, it's fairly similar, but what should they talk about in their statement of purpose? So this particular person is interested in microfluidics, especially building systems for single cell analysis to track the real-time cellular processes.
Yeah, I think if I may go, Marisa, first, if that's okay.
Yeah, of course.
Okay. So yes, so obviously you have to come to the program, okay, and obviously the program accepts the students, not individual faculty. So you have to enter into our program, which is a PME program through masters in that. So that's something which program decides what they're looking for. And I know what they're looking for, but I think Marisa will give you a better answer. But in terms of my lab in particular, since you asked this question, I don't want you to be expert in everything to come what I do. No, I would like you I would like to read that how motivated you are to come to Brown or a particular lab you are, and to see that how you're gonna contribute to our missions and how your background helps us to get to that level. So that's where we are looking what we are looking in that application. So we get lots of applications, as you know, as a Brown is a very reputable college. The what we are looking for students who are motivated, who would like to actually come and then not only build their career, which we are motivated from our side to do everything possible when you're at Brown to make sure that you are on the success path to your dreams. But also we are looking for people where we have lots of ideas and would like you to do that and give us solutions, okay?
So anybody else want to talk about the statement of purpose and what applicants should put in there?
I'm gonna say real quickly, especially for PhD, it's important to at least mention the faculty that you're interested in working with and for the areas that you're interested in working with. There might be other faculty that are recruiting that aren't specifically the ones that you're interested in, but if you talk about the general areas that you're interested in, or if you're open to all areas, talk about that. If there's a specific area that you want to work in and you don't want to work in anywhere else, graduate school is about making this match between you and schools and programs and faculty. You don't want to go somewhere, even if it's the top school in the world, if it's not going to be a good match for you. So find that match there. give us that information to see whether we can actually match with you as well as you want to match with us.
Ahmed, do you have anything to add to the statement of purpose? What do you like to see in the statement of purpose?
Generally, I just like to see what I look for in graduate students is passion. So whatever you're interested in doing for the next few years and as a master's student or a PhD student, talk about it with enough passion to show that you're actually really passionate about this. Because I'm kind of skipping to the next question here, but like, what skills do you look for like the most important thing is this person passionate enough to go through troubleshooting in the lab and do something new that no one did before? If the answer is yes, you can learn techniques, you can learn everything else. But if you're not passionate enough and it doesn't show through your statement, that's the key, I think, that I look for in research statements and students in general working in my lab. If you have the passion, in my lab at least, can teach you, and I think most labs can teach you how to do the work. But you have to be really interested and excited to do it.
Yeah, and I would add that my best advice on the personal statement is that you don't have to be eloquent or craft this, super engaging story that encompasses like everything you've ever done in your maybe undergraduate career or high school and undergraduate career, but really highlighting the skills you have, skills you want to learn, even if you don't quite know potentially what you want to get out of your career, those sorts of things. Again, you don't have to be eloquent, but I would say you do have to be detailed. So lots of examples and lots of specific information, I think, is very helpful to us as all of us are application readers. And I think I'm going to go to, because this is a really great question. What specific skills do you think are lacking in your lab, or what skills stick out to you in incoming students? And this could also include soft skills, which love this question.
I'll speak to the soft skills. So, or I'll speak to all of it, but one thing that I do when I recruit students, I never sort of relay. So we don't actually do the admissions. The program does the admissions, but the faculty do give our input to the admissions committee on which students that we're interested in taking. And then the master's students, once they're arriving and they're interviewing with with our groups, that's also sort of a point where the faculty gets to weigh in. I definitely do a lot of the talking and interviewing with the students, but I always have my lab talk with any prospective students, and that gets to the soft skills. If you can't work with people, if you aren't someone that's going to mesh with the culture that I have in my lab and going to make it stronger and better, then it's not someone that I want to bring into my group, because I have to protect the people that are in my lab that are currently doing their PhD, master's thesis, undergraduate theses. I want to have this great environment where everyone's excited to be and everyone's really collaborative and supportive of each other. And so it could be the most intelligent person in the world, but if they can't get along with everyone else in the lab, I don't want them in that lab. So soft skills are really important. Being able to communicate with each other, being able to work well with others and help others. That's really, really important. In terms of skills that are missing in my lab, oftentimes that depends on sort of the projects that you're chasing. You all are very intelligent people. The students that we get are amazing. Any skill can be learned. We have no one in our lab that can't learn a skill. So it's not like we're just looking for someone that will fill a little spot. We know anyone can learn those. It might be faster if you already know it, but it's not like any skill is impossible to learn. That said, sometimes there are things like animal work, where some people have done it and know that they're comfortable doing it, and other people have done it and they know that they never want to do it again. And there's other people that haven't done it and they don't know whether it's going to work out. So that can be sometimes a factor. If you have a lot of projects that involve animal testing and you need people that can actually do that type of work, then that could be a skill that a given faculty member might be looking at.
All right. Anybody else on skills? Trisha.
Yeah, so because I don't have a particular lab here and I'm new here, so I'm just speaking in general for graduate students, which we learn. I think most of us also learned maybe a hard way or someone guided us as mentors. Is I think you need to come with the mindset that you are going to do tedious, maybe daunting work in the lab. And there will be ups and downs there, but you need to have an open mind. And like Eric said here is, I think a lifelong learning attitude, and also communication skills. I think that's something if you don't equip with, as long as you're willing to immerse yourself in an environment where you want to communicate with people, and that's something you can build on. When I talk about communication skills, I think it's both oral and writing for graduate students. So I think that's very important. If you can write and communicate your ideas to whoever the audience is, but in a very clear, logical, concise way, I think that's you successful.
All right. Anyone else want to tackle the skills question? I will just throw this question out here because it's a really great question. As a prospective PhD student, is there a way to see which faculty are actively recruiting students? It's a really great question. Probably, so I'll start with some of our reactions is I feel like a lot of faculty are always looking for students, whether they might have funding in a particular year. I will let some of the research faculty talk a little bit about that, but I do think that faculty in general are kind of always looking, but maybe Ahmed, you can start with this.
Yeah, I was just gonna, so I think the easiest way, if you're really interested in someone's work, reach out to them by email. I reply to many emails in that vein. Second, I think, like Marissa said, most faculty, myself included, if you're the right person and the right fit, they will make it work. But yeah, an easy way is just to approach the faculty that you're interested in, write them an email, try to chat with them before, after putting in your application.
Anyone else?
I think,
Oh,
yeah,
yeah.
I think what Ahmed said is right. Actually, I just want to everything is right. I think the for PhD students actually, so obviously our director of PhD programs are not here. They would know the real answer. But I think if you are passionate about certain faculty research or area or cancer or something, do approach faculty, as Ahmed said. And I'm going to ask in my particular situation, I think I get lots of emails, and sometimes I miss replying email. And so don't, and everybody gets lots of email, and when you guys get lots of email these days. And so don't get discouraged that in case of mine, I say, because one particular student said I didn't reach out to him. So it's just you just approach, you just refresh the email again, and obviously I will respond once I catch it and then do it. No problem, actually. So don't get discouraged if you're a faculty for any place, even not this university, but any other university. Don't reply, because we as a faculty are in email fatigue right now, in a sense that we get too many emails, especially this time with lots of students approaching us directly and all that. So just keep pursuing that, and that's the best I can say. Don't think that we are not interested unless you hear from us, but keep pursuing that. That would be my request. So please don't think, at least my case, it I reply means I'm not interested in you. So
Yeah, I just chime in also that there is a distinction between sort of master's students and doctoral students. In one case, the faculty is funding fully the student in the doctoral student case. And so, when we're asked whether we're going to take a doctoral student, a lot of times that depends on our available funding to be able to support that doctoral student for 4 to 6 years. Sometimes faculty have funding in place already, and they know for sure that they are taking a student. A lot of times we have grants that are pending and funding sources that are pending, and we would love to, and if those grants get funded, we would be taking a graduate student as soon as possible. But sometimes we don't know. And so, if students reach out fairly early on in the application process, we'll oftentimes say, I don't know yet. We'll know better when it gets to actually the time when we're actually doing admission decisions. Then we can say, hey, yes, we have funding available. We can actually take the student. That doesn't help you right now decide whether or not you want to put it in an application. But hey, you can talk to Dr. Gray, and she's giving you a waiver. So there's nothing that hurts you to put in an application just in case that faculty member that you're looking for does end up having that funding. And again, just like Dr. Apata mentioned, if you contact a faculty member and they say, no, I'm not taking students this year, and that's the only faculty member you want to work with, then don't apply. That there's not any reason to go a place where you don't want to work. But if hopefully when you apply here, there might be multiple faculty and multiple labs that you're interested in working on. We do overlap in a lot of types of research. But yeah, for the master's students, definitely reach out. You can always reach out. The admissions process there, it really depends on the faculty, how many students they want to have in the lab, what type of research they're doing, and how you sort of mesh with that. And you can always reach out with faculty members if you're a master's student, and usually get a little bit more clear response on whether or not they are taking students. The funding issue is not as connected to it.
Yeah, that sounds great. In that vein, I just want to highlight a couple of things. So I did say in the intro slides that the PhD program is guaranteed 5 years of funding, but I do have some questions about master's funding. So Brown usually, and this doesn't just happen at Brown, this is most master's programs across the country are usually self-funded, but we do have some types of financial assistance and jobs that you can apply to. So first is our co-op program. Again, that's a 6-month work experience where you get to keep all of your salary. Second is we do have partial teaching and research assistantships. So once you are a student, you are able to apply to those. And typically those range, you can also apply to on-campus jobs as well. They range, I would say, usually I see around $2,500 to $5,000 per semester, depending upon the work that you're doing in those positions and how many hours you're working, essentially. We also have merit-based and need-based scholarships that you are considered for when you apply, so you don't have to do anything extra. And the last thing that is something I'm really excited about is if you're in the research track, there is an academic subtrack for those who are interested in maybe applying to PhD programs. You can apply to that subtrack and apply to receive a $5,000 stipend to complete research in between the summers of your first year, or in between your first year and second year in the summer. So we do have some options available. So hopefully I answered those questions. Let's see. Does anybody want to talk about the open graduate education program for PhD students? Because that's a really neat program option for specifically PhD students. I don't know if Eric or Anubhav, I think Eric, as a former director of graduate studies, might have knowledge into this, but Anubhav, I know have had students complete the open graduate education program. So if either of you want to jump in, that would be great.
Well, Eric was my boss, so I would like Eric to start.
Sure. So the Open Graduate Education program is sort of a unique feature at Brown. It allows someone to get a master's degree in an area of research that, at least for the BME program, is somewhat complementary and related. The program overall at Brown is not restricted to that for some other programs of study, but the way that BME has always run it is that doing a PhD in a scientific engineering discipline is really hard. It's really time intensive. It's really, concentration intensive. And so to add on a master's degree, it really needs to be something that furthers your PhD, makes it better, makes your whole outcome better. And so that's sort of been the deciding factor in terms of approving applications to even go into the open graduate education program. We've had a number of students do it. It can be a hard fit because, again, a PhD requires a lot of work. And so it's really a special person that can be able to do all the PhD work, keep up on the research, keep up on all that stuff, and be in great standing there, and still be able to take all of the coursework that's going to be required for a master's thesis somewhere else. And it is just coursework. You aren't doing any other. It's not like a research thesis based master that you're doing in any other program. And so people have sometimes done the one program that I remember multiple students doing is public health, and I'll have Dr. Tripathi talk about that a little bit more because I know one of his students, who was an amazing student, ended up doing both of these. But it is really really hard to do, and it is also a competitive program to get into. So just with my DGS hat on, past DGS hat on, you come to a PhD program to do a PhD, and your top degree is your PhD. The master's degree is just collecting letters with your name, and it doesn't matter nearly as much as that PhD that you come out with. Your reputation and your abilities are based on that thesis work, the papers that you publish in that thesis area, and then on your thesis work. If that's connecting chemistry, public health, computer science, that comes out in your thesis work. You don't need extra degrees to get that. But if that's something that you want to chase, we have had people do that, and that's something that we allow. And sometimes it works better than others, depending on what type of research you're doing. Dr. Tripathi.
Yeah, I think it's all up to you. If you, Eric said very, very right. Actually, if student can handle this both sides. So my student actually published from both sides, okay, which is outstanding, and we like that. And actually, it makes our program go up in rankings and everything, and then it makes a good connection between public health. For example, my student was in public health and the BME program. So, but the student is not that I'm saying student didn't sleep, but I'm saying the student is very sincere and meeting the challenges of and merging actually to very to her innovative mind. She merged actually the PhD topics she was doing with me, even though they were industry driven, aligning with the public health issues. Like preeclampsia, for example, she worked on, or like HIV detection in Dominican Republic, or then she went to Peru to test our device, which you can actually use in the field to detect actually HIV patient samples and other diseases, and that's a public health issue. So she merged these two ideas, and it was she made a lot of people happy actually, both in public health and obviously BME department. And so that's very outstanding stories actually come, and we encourage, if you're willing to actually do these utilize these things, we are very encouraging, but the onus on you to make sure that you can manage both in your time.
Thank you so much. The Open Graduate Education Program is a really great program here at Brown. So thank you both, Eric and Anubhav, for sharing about that. I do want to address this question: when are acceptance letters usually sent out, and how are interviews conducted? And I'm going to answer this in two different ways. So for the master's program, usually our acceptances are generated on a rolling basis. So usually from when you submit your application and it's completed, so all of your letters of recommendation are in and those sorts of things, it usually will take us a few weeks to review the application, and then we will get a decision back to you. I always like to say within 2 weeks, but sometimes it might be a little bit more like 3 weeks, but we should have it relatively quickly, a turnaround time. Now, for the PhD students, it's a little bit more structured because there are interviews. So our application deadline is December 1st, and you might receive an additional or a initial Zoom interview by the end of December, early January. And then we typically invite students to campus in February, March. So really, our acceptance letters typically go out by early March, or I would say end of February. Early March might be a little bit later, but usually we try to get those in by early or late February. All right. So, Anubhav, did you have anything to add?
Yeah, I saw your comment that we are ending the session. So I want to speak
Yes.
to, so I think, and Eric, you can speak too from the PhD program also. See, I think our program, and obviously big thanks to Marisa, provides amazing students to us actually to work with them, and we learn from them. And it's just my closing statement, if you can't call it. So I think I've been beneficiary of master students from Marisa's program, and also there's another program called Biotechnology program. Amazing students, and they are outstanding actually, and they work really hard, and then they move on to their career, whether it's to PhD or to industry and everything. And so Brown is a really a good place where you can realize your opportunities with your career aims you're looking for. So my request is to you to apply, as well as and also you tell your students, outstanding students in your universities, to apply to Brown, because we would like to make sure that we align with you guys well, and make sure that we get opportunity to work with you in that fashion, and then you also to get excited about that, how you can help Brown or BME program in this case, or any other program you join at Brown, to put your energy in, your innovation in, your curiosity in, and to make sure that we align with our programs, and give us speed in that direction, and also enjoy your time here. So I'm very thankful to get opportunity to talk to you. As a master's, I have a very big group in my lab, and I would love to get opportunity to work with you if you guys apply, or should you choose to apply to Brown and come to Brown. I'll give it to Eric, so if you can take a bigger picture view here. Thank you, Eric.
Are we doing closing statements?
Yes, that was a perfect roll into. There's a few more questions still in the Q&A that are master specific. So I was going to answer them after. Maybe you can all go through your closing statements, and we'll go from there.
Sure. I mean, my closing statement is just, I think Brown is a fantastic place to get a graduate education. There's lots of great schools around. You know, you get to choose as top students oftentimes where you go. And I think Brown has a lot of faculty members that truly care about educating their students, both in the classroom, but mentorship is really important in the lab, teaching someone how to be a good scientist, be a good ethical scientist, how to do things well. Like, that's really important. And it takes time. It takes a lot of effort. And faculty really take a passion to teaching and training students here. I think that's what I love most about being a faculty member at Brown, that so many of my colleagues have that same view on education. And it's not just, we're going to churn through students. We actually care what our students are, and we care what they do afterwards, and we want the best for them, whatever path they take from their career. So keep that in mind when you apply with Brown. My lab is always full of undergraduate, master students. We have a lot of fun in our group, and I think that's the case across Brown. So, that's all I have for my statement.
Great, thank you. And Amit?
Yeah, I mean, I think Eric and Anubhav already said most of what I would say, but I mean, the one thing is for you as, incoming graduate students, you're going to spend a few years doing something during your graduate training. That the nice thing about it is that you can pick what you want to do and you're not told what you do. So make sure you're excited about doing it. Ask questions to the professors that you're applying in their labs about their work. Try to, get to know what you're getting yourself into in the next few years. To be, to continue to excel in those years to set you up well for the next stage. As Eric mentioned, Brown BME program specifically has a wide range of multiple research interests that span a very large many disciplines that, and the nice thing about Brown too is that we're not too big or too small, so most people know what everyone else is doing. So there's lots of collaborations happening. For example, my lab, just on this floor that my lab is on, 3 other labs are using our tools in their research, and we're collaborating and we're writing up papers together now. So that just tells you the amount of, everyone knows everyone else around at Brown, and most people collaborate a lot. So it's a very collaborative environment that I think is beneficial to students, because students then get to experience that part of being in a lab and not being in a separate closed lab, and so on and so forth. So it's good for mentoring students. It's a good environment in general to learn about different disciplines and so on and so forth.
And Trisha?
Well, I can only speak with my very limited experience here, but I want to first say that based on my interaction with the students here, those professors, that they're very talented, they are very persistent, they are hardworking. So you are going to immerse yourself with peers like that. And those will be your connections in the next 5, 10, maybe 20, 30 years, right? So you got good peers here. That's the first thing. The second thing is similar to Professor Ahmed said here, is that it's very collaborative, but also the location is central. For BME, we're located near Boston. So Boston and then North Carolina, the Triangle, as well as San Diego, San Francisco Bay Area are considered those big bio centers. Also, I think we're very close location-wise. And the third thing I just want to say, you are here for 2 years or maybe 5 years or even longer. So you are going to live a life here as well. So Providence itself is very pleasant to live, and you are going to immerse yourself not only into academia, but also culture, food, everything. So.
Yeah, great. Well, I am still going to answer a few questions if you have them, but I would like to thank our panelists. Thank you so much for your time and your great advice. So thank you very much. And feel free to sign off so you don't have to listen to me answer more questions. But I did want to answer, thank you all for the participants in the chat for saying thank you for showing up. That is, I think, the most important thing. So thank you for doing that. I did want to answer a couple of other questions. So I wanted to differentiate with the master's program between the different program and options we have. So we have our Master's of Science, which again is typically a 2-year program. We also have part-time options as well. So it could extend beyond 2 years if you are a part-time student. But speaking for full-time students, we have a thesis, which is faculty mentored. It's over 2 years. You're working on a dedicated project in a lab, like with one of our research faculty, like the ones that were here today. Although this was just a sampling of our research, we have lots of other research areas as well. Some areas we didn't quite cover, but which is okay. We have a vast portfolio of research. And our design, what differentiates that is that it is mostly a design faculty and clinician mentored experience where we help you kind of set up the project in the first year and do some initial prototyping. And then we're going to get you involved with some of our innovation and entrepreneurship courses in the second year so that you can really think about how to carry those technologies forward and learn a lot of these different industry type soft skills that you'll need. So that's the Masters of Science program. For the full-time co-op, and I should say the Masters of Engineering, that one is coursework based only. So it's non-thesis. It can be done in as little as a year, but I have plenty of students that take 3 or 4 semesters to complete it. That pairs really nicely with the co-op, the Masters of Engineering, but you can actually do the co-op in the Masters of Science program as well. It is a little bit more organizationally challenging because you have to fit in a thesis and a co-op, but you can do the full-time co-op in one semester. So that's a 6-month co-op. The internship would be something over summer break. So an internship is shorter, so probably around 3 months. It's usually done over summer break. You can elect to do one or the other, essentially, what works with your schedule. For the international students, you're definitely able to do the co-op program, but again, it's one or the other. Domestic students have a little less restrictions on that. Hopefully that answered that question. For the international students application, there isn't anything really different. That I would say, yeah, nothing I can really have. The only major difference is that you're if you are attending an institution whose primary language of instruction isn't English, you'll need to submit language scores. But so that's either the TOEFL or the IELTS. But that's pretty much, I think, the only major difference between international students and here. The Masters of Engineering can be done in as little as 1 year, but can also be 2 years. So actually, probably most of my students do it in 2 years or sometimes 3 semesters as well. But it can be done. I say it can be done in as little as a year because it can. You can take 4 courses each semester, but a lot of people like to spread it out. That was rapid fire. We're at 1 o'clock. So thank you. Thank you for those that attended. For Paul, so we have tuition. It's charged by the course. So right now we are about we have 8 courses that you have to take. So we are about $9,000 per course. So we're looking a little over $70,000 for the 2-year masters. So that's tuition for 8 classes. So even if the Masters of Engineering would cost the same as the Masters of Science because it goes by courses. And I do have a link. If you email me, I can send you lots of financial information. We have a website dedicated to financial aspects. So feel free to do that. But thank you so much to everyone. And thank you, Trisha and Victoria. I'll touch base with you both later and have a great day.